Hello guys, hello. How are you? This is Mr. Bigirimana talking, Mr. Bigirimana. So my Facebook is Jane Christian Bigirimana. So I'm taking over from Miss V. I call her Miss Mickey, but for you guys, it's Miss V. Okay, when you're addressing to me, you're gonna call me Mr. B or just so. Okay, so I'm very excited to be with you guys. It's my first time, guys. Hey, I need to warn you that. So I'm not as perfect as Miss V was, but I'm sure you and I will get along just fine. Okay, just a couple of instructions which I've been told. I've been told that you guys, you need to switch off your video feature. Otherwise, they're gonna have to remove you from the platform. So please, if it was on, make sure that your video is off. Are we together? Okay. All right. So let's start. Okay, so we're gonna talk about electricity and magnetism. But today's topic, it will be all about what we call electrostatic. All right, electrostatic. Right, so now, if you go to electrostatic, if you're using the book called Mind Action Series, it will be on page 189 and up to page 201. Now, if you're using Study and Master, it will be on page 190 to 197. Okay, so that will depend on any book you're using. For me, this is what I'm using. Somebody raise a hand. What's her name again? Something to ask. Okay, let's see. Can you please raise your hand again? Yeah. Talk to me.
Hello.
Hello. Yes.
Is our chat supposed to be disabled or is it fine? Is it because we can't ask any questions in the chat box?
Your checkbox, I don't think, for now though, I don't think you, for me, I don't know. I'm still gonna ask because like I said, it's still new for me. So yeah, I don't know whether if you put it on, then how it's gonna work for me. But I'm still gonna ask, please bear with me, okay?
Okay, sure, thank you.
All right.
The chat is switched off for the first 5 minutes of the class. After the first 5 minutes, the chat will be switched on and then people can continue to ask questions there.
Okay. Thank you, Kobe, for making that clear for us. Okay. All right. So let's go with it. Okay. All right. So we're going to talk about electrostatic. Electrostatic. So this, I can divide it into two words. The first word which come here, it's electro, up to here, which basically means electricity. And then the second one, which is static, means stationary. Okay, so in other words, we'll be talking about electricity of a stationary body. Quite interesting. Okay, example. Now, this is something which you live with every day. Whenever you take a pen, you brush it with your hair, you are charging. That's what we call electrostatic. Also, an example which most people come across is putting on a jersey made of synthetic wool, and then you hear it starts crackles. Okay, it's starting crackling. Okay, or if it's at night, you'll see sparkles. That's also is due to electrostatic. one of my worst experience is the shock from a car door. So I don't know. I mean, it's looked like I've got that problem. Whenever I'm about to touch my car door, I'll be shocked. Okay, now, so let's talk about electric charge. Now, electric charge, so we're gonna go back a bit, and we're gonna go back a bit. We know that material, from what we know already, material are made of atoms. That we know, okay? And also, atoms, okay, somebody's, let me check, sorry. Okay, atoms have protons and electrons. Now, we know that protons are positively charged and electrons are negatively charged. People, that's electricity we are talking about. The fact that we are talking about charge which are positive and charges which are negative, we already talking about electricity. Okay, neutral object has also, we know that neutral object has a number of protons which is equal to the number of electrons. Okay. Okay. So when a object is positively charged, it means it lost its electrons, what we call in scientific words, electron deficiency. Okay. Gina is raising a hand. Okay, Gina. Gina. Jenna. Hello, Jenna. Okay. Can you please raise up a hand again, Gina? Oh, Jenna. Yeah. Yes, Jenna. Hello. Okay. I think.
Apologies for the interruption, teacher. Can we just remind the learners that should they raise their hand and get unmuted, they must immediately continue to speak. If they do not speak within 5 seconds or so, we will mute them again and then remove them from the class. They are wasting time. Thank you.
Okay, all right. All right, Gina, I'm sure you heard about that. Okay, so again, positively charged, positive object or positively charged object, they are positive because they've lost electrons, what we call electrodeficient or electrodeficiency. Then negatively charged, they've got an excess of electrons. So one is giving, the other one is receiving. So the one which is receiving electrons will be negatively charged. The one which is giving up electrons will be positively charged. Right. Charges. Charges, we symbolize charges by the letter Q. Okay. All right. And then they also have a unit which we call coulomb, symbolized by symbol C. Kobe, I keep seeing chat. Should I go to the chat and check? Kobe?
Yes, sir. The chat is there for the learners to interact with you, so you can actually interface with the chat. They are trying to ask you questions, and they also indicate to you to either go slower, faster, or that they don't understand.
Oh, okay, all right. Let me check. Okay, so it's going. Oh, say I'm going too fast. Oh, sorry. Okay, and then Talita, I don't understand. Okay, all right. Let me go again. I'm gonna just start again slowly. Okay, all right. So we said that material are made of atoms. We all know that, okay, from the previous topics. And then we said that atoms, every atom is made of protons and electrons. Obviously, there's a neutron, which we ignore for now. Okay, now, yes. Okay, so now, because they are like protons are positively charged and electrons are negatively charged. That's we know already. Electrons are always negatively charged, and then protons are positively charged. Now, whenever we're talking about these charges, we already talking about electricity. Later on, we're still gonna talk more about that. But for now, though, what I want you to understand from this is that whenever we hear positively charged, negatively charged, we are talking about okay, yeah. Whenever we're talking about that, we'll be always talking about electricity. So charge have a unit, and the unit is called coulomb. Okay, and the symbol for the charge is Q. All right. So with your permission, I can go on. All right. All right. Example of a charge is the charge of an electron, which is 126 10 to the power exponent minus 19. Okay, we'll come back to this at the late stage. We're gonna talk more about the charge of an electron. Right. Now, let's go how to charge a body. Okay. Now, like I said, this is something we all know. Okay, so we all know already about charges. Oh, sorry, oh, this one. Right, how to charge? There are three methods to charge a body. Okay, the first one is by friction. And friction, people, this is something you all know. It's what we call rubbing in daily use. Rubbing, whenever we're talking about rubbing, we're talking about, oh, we are talking, okay, Miss P, we are talking about electrostatic, okay? Electrostatic, yes. Okay, so three methods of charging a body. So we can charge a body by friction. Oh, somebody is sending a chat, let's see. Okay, all right. She started by friction. So this is rubbing. As you can see here, you've got some kind of a ruler. Okay, and then we've got a piece of material, and somebody is just rubbing. Now, depending on the material, depending on the nature of these two, one will take the electrons, and the other one will take will give away the electrons. So now you can see, for this particular image here, we've got the material giving electrons, and that's why it's positively charged. Remember what we said, when you are giving, you are positively charged. Giving electrons, because electrons are negatively charged, so become positively charged, and this one here become negatively charged. Okay, in other words, this one here, the material is giving up electrons, and this one is taking the electrons. The second way of charging, it's by contact. Okay, now by contact, somebody is asking about Oxford textbook. I really don't know about the textbook Oxford, because I'm normally using two only, mind actions and electrostatic. Somebody was raising a hand, so again, sure. Hopefully she's gonna raise again the hand. Okay, so let's go back. Three methods of charging a body: by friction, rubbing, by contact. As you can see, one is positively charged, the other one is negatively charged. Okay, you force them to, they attract anyway, so you make them in contact, and then after that, you can see they are both negatively charged, depending on which one was having a large charge. Okay, we're gonna talk more about that, as you can see, but the contact is here. They were here as an A, there was no contact. Here, there is a contact, and there's what we call transfer of electrons, as you can see, symbolized by this arrow. Okay. Oh, by the way, E, that E exponent -1 is what a symbol for electrons. So whenever you see that E exponent -1, guys, always remember that we are talking about electrons. Okay. And then after that, they repel. Okay. This is goes this way, and this one goes this way. That's because they got the same charge. We're still gonna talk more about that. Okay. There's a question. Yes, they've unlike charge. That's why they are repelling. Yes. 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 It's more like magnetism. We're still gonna talk about that too. Yes. Unlike charge, the attract. Yes, we're gonna talk about that. Don't worry. Okay. All right. And then by induction. Okay. Induction, which more or less goes with what we call polarization. Okay, so in the next slide, you'll see what we call induction and polarization. All right, there we go. We've got two bodies or two balls which are neutrally charged. These two are neutrally charged. Okay, they are neutrally charged. Now we're bringing a body which is positively charged. Okay, this is not a cross. This is just they are symbolizing a positively charged. Yes, they don't have a charge talita. They don't have a charge here. For these two, they don't have a charge. They are neutrally charged. Okay, so the number of electrons and the number of protons are equal. So it's neutrally charged. Okay. Okay, now, so we're bringing closer a body which is positively charged, as you can see. This is not a cross, is a positively charged. Now, check the magic which is going to happen. You can see here on charged ball near a positive rod. Okay. Now, as you bring it closer, this rod, what happens? Check what is happening. The negative, the charges are separate. They are separated. Now they separate themselves. The charges. You see, the negative goes toward the positively charged rod. Okay, and then the positive, the rod which was positive, now they are a bit away from the rod. So the negative come closer to the positive, and the negative, the positive of the ball goes a bit away from. Now, this separation of charges, that's what we call polarization. And you can see here, the rod even here, ball are polarized. And when they are polarized, because they are presenting the negative part, which will be attracted to the positive charge rod. Okay, I'm gonna repeat that. The two rods are neutrally charged, which means they are not, they are neutrally charged, which means the number of electrons and the number of the number of electrons and protons are equal. Now you bring closer a rod which is charged, positively charged. What happens? There is a separation of charges. Now this separation of charges is what we call a polarization. Now, then there is a contact. Okay, after contact, now you can see, now these two balls are positively charged. Now, because they are positively charged and that they have like charges, now they repel each other. And that's the arrow you can see here. So the distance away from each other. Okay, so this is what we call charging by induction. So this polarization, and then after that, there is also induction going. Okay, now electrostatic force. Let's talk about electrostatic forces, which you already know. Okay, let me go to the chat. I can see somebody. Oh, okay. All right. Somebody already given her an answer. Okay, electrostatic force. Okay, so now you already know that. Somebody already told me about that. They've got same charges, like charges. They repel. Yes, that's the force of repulsion. Okay, and then unlike charges, positive, negative, they will attract. Okay, so we've got forces of like charges, they will repel. Okay, as you can see, this is the situation in A. You've got the rod here, and this one here, this is negatively charged, and this one here is also negatively charged. Now the arrow is showing that they're just gonna repel each other. Now because this one is hanging, so it's gonna be the one to be pushed, the one to be pushed away. Same situation on B. Positively charged, here it was negative, yes, positive, positive, positive. Again, the repulsion force is applying, okay? And then, yes, it's symbolized by these, okay? And then also, unlike charges attract. So we've got, if we've got positive and negative, as you can see, they will attract each other. So they will come closer together. Okay, so that's the situation on C. Okay, situation on C is, okay, all right. So the situation on C, the situation on C, it's symbolized the attraction force. Okay, as you can see, the attraction force here is applying. Okay. Now, okay, now what induction means that you are just bringing closer. You are bringing closer, but without touching, and then the polarization will occur. Okay. Now let's go to the charge conservation. Okay, so charge conservation of electric charges. Okay, the law of conservation of electric charges says that the net charge Okay, so now this is a law, okay? A law of conservation of electric charges. The net charge of an isolated system remain constant during a physical contact. What that's supposed to mean? Okay, I'm gonna repeat. The net charge of an isolated system remain constant during any physical contact. All right, so let me put it in English. I like that word. When my learners are telling me, please, sir, change it into English now, because it's like I'm not talking English, okay? All right, what we're saying is, it just means that if you're starting with a certain charges, you end up with a certain charges. Okay, so I mean, you end up with the same charges. Let's say if you're starting with 2.8, like here you can see on this thing, you've got 2.8 coulomb. Okay, and then you've got a 0. Okay, there is a contact. Remember, they said the net charge of an isolated system remain constant during a physical contact. So when there is this contact, what happened? Now, after separation, you've got 124 plus 124, which is making exactly the sum of these plus these. 224 plus 224 is equal to 2.8. Okay, I can see what the equation of the bottom of the page. I'm still gonna talk about this later on. The equation is this, but I'm still gonna talk about it. The equation of the law of conservation of the charges. These relates, we'll get the Sandra, Gina, and Miss P. Okay, we'll get it. Okay, so, but I want you first to understand the law. The net charges, let's repeat it together. The net charge of an isolated system remain constant during a physical contact. In other words, whatever you're gonna start with, that's what you're gonna end up with. Charge on the left side is equal to the charge, the sum of the charge on the left side is equal to the sum of the charges on the right side. That's what we call remain constant. Remain constant. Though it means there's no charge lost, there's no charge gained, but it just remain constant. What you start with, that's what you're gonna end with. Okay, now, all right. Example, there we go. This is the example I was explaining. So then each ball, if you are trying to quantify the charge on each ball, okay? If you're trying to quantify the ball, to quantify the charge on each ball, so you're gonna use this equation. People, like I said, I'm still new. This was supposed to be on a box because this is a low, this, and this low too. Okay, so because I'm new and yeah, I'll get to perfect myself slowly. Okay, let's see, equation. Don't know what page doesn't master. Okay, I said it's 190. Okay, so 190. So right now we are on page 195 on Study Master. Okay. Okay. Yeah, actually we are on yes 194. Okay. 194, 195. Okay, Study Master. All right. So if you want to quantify, if you want to find the charge on the ball after they've already after contact, and separation. So we're gonna use this law here. This, I'm gonna call it even equation. So Q, which is the charge on each of the two balls. Remember on the beginning, the first ball was having 2.8 coulomb and the second one was neutral, which means it wasn't charged. And then after that, you end up with the Q1 having 124 and 124. Okay, so they ended up sharing basically what was on ball 1. So Q1 is like the charge on this ball here, and Q2, the charge on this ball. And then now the charge, these two charges, okay, on each ball become that one. All right, let me check. There's a message here. There's a question. Okay. No, what? Okay. All right. Check. See. Okay. That's the charge. Yes, you can call it the total, but it's a charge on each ball. I don't want to call it total really, but I'll call it the charge on each ball. Okay. All right. Now, so let's go with an example where we're going to apply the law. Okay. There we go. Okay. Before I go there, there's a chat. Let me see whether somebody is getting low. Okay. All right. Is polarization and induction same thing? Can I say that's the same thing? Polarization, it's when there's a separation of charges. Induction, now you are charging. It's after charging. That's what I can say for now. Okay, but probably I'm gonna explain more about that at the later stage. Okay, all right, now let's go to this. Two small identical charges conducting sphere suspended on a long silk thread are free to move. These two charges carry a charge of 2 nanocoulomb, and the other one is -5 nanocoulomb. Okay, so we are given the first charge, which is positively charged, nanocoulomb, and the second charge is -5. Okay, Gina, she got it right. Okay, yeah, Gina, you got it right. And then when come into contact this, all right. So and then, okay. Now let's go to the question. Calculate the charge of each sphere after they've already touched each other. After touching. All right, some people got it right. I like it when some people are interacting with me. Well done to you guys. Hey, I'm gonna like this class. Miss V was right. You guys, you are very, very active. I love it. Love it. Yo. Okay, so let's start with our equation. Okay, it's like this, but since I don't know how to put it this, so I put it this way, which is more or less the same thing. Q1 plus Q2 over 2. Like I said, I'm still new. Please bear with me. Okay. All right. Yes, so you add them together in a bracket and then you divide by 2. Yes, talita. Okay, and then so Q on each is equal to Q1 plus Q2 in the bracket, the whole thing divide by 2. Or just you can use this. Okay, Q1 plus Q2 over 2. Okay, then, okay, there you go. Put them in the bracket, you add them together, then you divide by 2. And then the answer is 125 nanocoulomb. Okay, nanocoulomb, people, I think you remember that nanocoulomb. Okay, something is falling here. Okay, sorry guys. Okay, nanocoulomb, we're still gonna, yeah, remember, I think you did that, okay? But anyway, we're gonna talk more about that. Right, so I'm gonna repeat again. So we've got two charges, identical charges, conducting sphere. One is got this, the other one is got these charges. Okay, they say calculate the charge of each sphere after they touch each other. After, okay, and separate it, of course. Okay, so there is the equation, which is so this one here. Okay, then you put it in your calculator, and then after that you get this. Okay, all right. Now, so let's go to the okay. Let's see what to get. Right, question one. Let's start with question one. Two identical charges, spit ball, touches each other and spring apart. Spring, which means separated, separate, they are separated. Okay, after touching, of course. The initial charge on the pit ball is 5, and yet on the B is minus 12 nanocoulomb. What is the charge on each when they spring apart? So after they being separated. Okay, and then question 2. All right, guys, I want you to try that. I'm sure most of you are busy trying right now. Please try, and then I'll be looking at your messages and see how you're doing. I'll give you, let's say, 3 minutes, 5 minutes. Is 5 minutes okay? I believe 5 minutes should be okay. All right, let me check your chat. Okay, Gina, you said you don't understand. Okay, I'm just asking you to do this one here using the law, the same law we just applied. Okay, and the same, the second one too. Okay, all right. Yeah, I see some answers. Yes, N must be in a small letter. We're still gonna talk about that later on. This, yeah, I can see. Yeah. All right. Okay, I'm still here. I'm just looking at what you're doing. Yeah. Hakim, yes. Mm-hmm. Mm-hmm. Okay. Mm-hmm. Okay. Sandra, well done. Tabor, well done. Gina, yes, well done. Bushem, Talita, yes. Miss P, yes. Paya, yes. Mhm.
Teacher, we've got 5 minutes left.
Oh, okay. Okay. All right. Thank you. Okay. Okay. All right. So let's go with question 1. Okay. We'll talk about question 2 later on. Okay. Now, most of you did well. Most of you did well. Okay, so let's go to the answer. Okay. Now, question 1 says that, okay, so we're gonna use the law Q. The charge on each will be a half of Q1 plus Q2. Again, the bracket. So this 1/2, you can put it this side, you can start with it, it's fine, it's the same thing, it's gonna give you the same answer. Oh yeah, sorry, yeah, it was supposed to be minus, oh yeah. Sorry. Yeah. Okay, so the answer was supposed to be minus 3.5 nanocoulomb. Okay, so unfortunately, even myself, I think I forgot to put a minus. So well done to all those who got minus 3.5 nanocoulomb. Okay, those who wrote 10 to the power exponent minus 9, it's also correct. In fact, that's the perfect way of doing it because you used what we call the SI unit. Well done to you all. Okay, those who got, it's not microcoulomb. This is nanocoulomb. N stands for nanocoulomb. Micro, we're gonna use another letter, which is like a, I'm gonna show you later on. It's what we call mu. Okay, and then the P is picocoulomb. Okay, it's 10 to the power exponent minus 12. Okay, and then question 2. Okay, question 2. Yes, I understand some of you didn't get to that, but anyway, it was supposed to be the same thing. Okay, the charge, the law. Okay, you substitute, formula, substitution, final answer with the correct again unit. Yes, nanocoulomb. Okay, okay, or 10 to the power exponent 4. Okay, so ball A and ball A will carry the same charge, so there will be a repulsion force. So that's why they're gonna separate them. Okay, so anyway, for now, you guys, yeah, I'm proud of you, but I just don't understand how some of you got 4 minus 4. I mean, did you? I hope you guys you didn't round off, and rounding off. I don't know. I hope you didn't round off. Okay, so yeah, I hope the correct answer was 3.5. Those who rounded off, wouldn't be very. So you're going to lose 1 mark probably, unless if
1 minute left.
How many minutes?
1 minute left.
Okay, all right. Okay, and then yeah, and then question 2. Okay, all right. Now let's just see some of your question. Why is NC? NC and PC NC and PC is nanocoulomb and picocoulomb. So we're still gonna talk about that tomorrow, because now the time is going, it's against us. I will try to put a slide for you, and we're gonna carry on with this tomorrow. We're gonna finish, and then I will explain about this nanocoulomb and picocoulomb. Thank you guys. It's been really, really a pleasure to be with you, and I'm very, very encouraged by your participation. If you keep me like this, I'll be more than happy. Very, very, very proud of you guys. Ciao, ciao. Thank you, Kobe, for your being next to me. I really appreciate. I really, 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 really appreciate. Thank you so much. Okay, see you tomorrow then, guys. Bye. Letabo want a question, a quick one. Okay, let's see. Let's hear Letabo. 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 Okay, Letabo is not talking. Okay. Thank you so much, you guys. We're gonna carry on from here tomorrow. Then we'll do some exercises, more more exercises, and we're gonna finish this topic tomorrow. Okay, all right. Thank you so much. Thank you for your being with me. Sending you all the love. Thank you. Bye for today.